Welcome to APCV 320 Computational Thinking and Doing. This will be the last module in our class, and we will be talking about UNIX and shell programming. Lecture slides were adopted from Professor Henry Wershan, Applied Computing and Computer Science Program Director, who taught this class during the fall semester of 2020, and from Dr. Li Xu, a Program Director for Applied Computing at the University of Arizona. In the late 20th century, UNIX was widely used for Internet servers, workstations, and mainframe computers. The main features of UNIX were its simplicity, portability, which is the ability to run on many different systems, multitasking and multi-user capabilities, extensive library of software, and hierarchical file system. UNIX allows direct communication with the computer via a terminal, hence being very interactive and giving the user direct control over the computer resources. UNIX also gives users the ability to share data and programs among one another. Since it began to escape from AT&T's Bell Laboratories in the early 1970s, the successive Unix operating system has led to many different versions. Recipients of the, at the time, free Unix system code all began developing their own different versions in their own different ways for use and sale. Universities, research institutions, government bodies, and computer companies all began using the powerful Unix system to develop many of the technologies which today are part of a Unix system. By the late 1970s, a ripple effect had come into play. By now, the under and postgraduate students whose lab work had pioneered these new applications of technology were attaining management and decision-making positions inside the computer system suppliers and among its customers, and they wanted to continue using Unix systems. In the early 1980s, the market for Unix systems had grown enough to be noticed by industry analysts and researchers. By 1993, most commercial vendors changed their variants of Unix to be based on System V with many BSD features added. Unix, an open standard owned and managed by the Open Group, is an enabler of key technologies and delivers reduced total cost of ownership, increased IT agility, stability, and systemability in heterogeneous environments, enabling business and market innovation across the globe. This operating system has an interesting history while showcasing a robust modern market momentum. The POSIX, certified by IEEE, and the Open Group certification program is a voluntary program but is required of suppliers who wish to use the POSIX trademark. Certification is open to any product meeting the conformance requirements. Linux is an open source, free-to-use operating system widely used for computer hardware and software, game development, tablet, PCs, mainframe, etc. Unix is an operating system commonly used in Internet servers, workstations, and PCs by Solaris, Intel, HP, etc. Mac OS is a series of proprietary graphical operating system which is provided by Apple Incorporation. It was earlier known as Mac OS X and later OS X. It's specifically designed for Apple Mac computers. It's based on Unix operating system. Shell is a Unix term for the interactive user interface with an operating system. The shell is the layer of a programming that understands and executes the commands a user enters. In some systems, the shell is called a command interpreter. When you log into a Unix system, a program called a shell process is run for you. A shell process is a command interpreter that provides you with an interface to the operating system. A shell script is just a file of commands normally executed by a shell process that was spawned to run the script. Those are some features of the shell for whatever you happen to be running is. The features are pretty straightforward. We will go through some examples of the wildcard expansion process through the lecture. So these are some common shells. Bash is widely used with Linux. Bash came from Bourne Again shell, is the free and enhanced version of the Bourne shell distributed with Linux and GNU operating systems. Bash is similar to the original but has added features such as command line editing. You can use any shell and anything you can do with This slide explains how to access the University of Arizona UNIX system from your home computer. After downloading PuTTY, fill in hostname as u.arizona.edu, port would be 22, and then click Open. PuTTY login screen pops up. Fill in login as with your Arizona login ID, type in password, then click Enter. The Linux subsystem interface pops up, and now you are ready to practice some basic commands. Command line basics. You have to press enter after each command you type to execute it. Some of the basic commands are ls, ls-al, top. To get back to the prompt command, press Q, then clear to clear the screen. As mentioned earlier, you have to press enter after each command you type to execute it. You can practice the other commands and check the output. ls command can be used in the following three ways. Number one, ls space dash small letter a will list if all files, including hidden files, i.e. files with names beginning with a dot. Number two, ls space dash capital F, which gives a full listing indicating what type files are by putting a slash after directories and a star after executable files. Number three, ls space dash small l gives a long The SSH command establishes an SSH connection with the target machine. This command uses one of the SSH secrets engines to authenticate and automatically establish an SSH connection to a host. This operation requires that the SSH secrets engine is mounted and configured. The SSH command provides a secure encrypted connection between two hosts over an insecure network. STTY space dash small a displays terminal settings as shown above. This slide shows some control characters. Unix understands several control key commands. Commands you enter by holding down the control key while striking a second key, i.e. Control C, Control U, and Control W. I usually use backspace to delete a line or word, but it's good to know host name gives you the system you are on as the host name. Uname will give you the operating system you are running. Who am I gives you the name of the person who is logged into the system. Cal shows the calendar. Cal 2 1973 shows calendar of February 1973. Date shows In this example, hostname gives you the University of Arizona Sage system as the hostname. Uname will give you the operating system you are running, i.e. Linux. Who am I gives you the name of the person who is logged into the system, i.e. Abu Agil. Cal shows the calendar. Cal 2 1973 shows calendar of February 1973. Date command gives you today's date. A process is a task that your Linux machine is currently working on. So if I type history, it will show the other bash that I just entered. CSH is the name of one particular command interpreter on Unix. The primary purpose of CSH is to translate command lines typed at a terminal into system actions, such as invocation of other programs. CSH is a user program just like any you might write. For example, when you open a browser, your machine creates a process for it. If I type bash, I just entered another bash shell. So if I type history, it will show the other bash that I just entered. In most Unix and Unix-like operating systems, the PS program, short for process status, displays the currently running processes. PS also means report a snapshot of the current processes. In this example, typing ps and ps space -u root will execute the commands as shown above. ps space -u root shows all processes on Sage server for all root commands by others. PID, which stands for process ID, then TTY, it says what started this process, in our case terminal we are in. If there is a question mark under TTY, it means the kernel started the process. And then time, which shows the time it took the job to run. That time is CPU time, not the clock time. And CMD means command used to man command in Linux is used to display the user manual of any command that we can run on the terminal. It provides a detailed view of the command, which includes name, synopsis, description, options, exit status, return values, errors, files, versions, examples, and authors. For example, when typing man grep, grep searches for patterns in each file. Patterns is one or more patterns separated by new line characters, and the grep prints each line that matches a pattern. Typically, patterns should be coded when grep is used in a shell command. The script command is used to type script or record all terminal processes. After running the script command, it begins recording everything that appears on the screen, including inputs and outputs until it exits. The command could be very useful if it's used to create a script of a set of commands that you execute every time. Script command is a quick way to get multiple commands executed at once, as shown above. The type script is written to the file specified by the file parameter. If no file name is given, the type script is saved in the current working directory with the file name TypeScript. If the file exists, the default behavior is to overwrite its contents. So the simplest way to view text files in Linux is the cat command. It displays the complete contents in the command line without using inputs to scroll through it. In this example, typing cat TypeScript outputs a script to the screen. In the original Unix tradition, command line options are single letters preceded by a single hyphen. Mode flag options that do not take following arguments can be ganged together. Thus, if -A and -B are mode options, -AB or -BA is also correct and enables both. The WC utility displays the number of lines, words, and bytes contained in each input file, or standard input if no file is specified to the standard output. WC stands for word count. As the name implies, it's mainly used for counting purpose. It's used to find out number of lines, word count, byte, and characters count in the files specified in the file arguments. By default, it displays 4-column output. First column shows number of lines present in a file specified. Second column shows number of words present in the file. Third column shows number of characters presented in the file. And fourth column itself is the file name, which are given as argument. If you want to get only the number of lines, you can use the command wc space -l space .bash_history as shown above. Bash allows for combining single character into multi-character options. As mentioned on the previous slide, Bash allows for combining single character into multi-character options. For example, typing wc space -l space -w or wc space -lw will give the same output. For most of the universal commands, you will be able to combine multiple characters because it's easier and quicker to do that. Bash divides each line into words at each white space, spaces or tabs. The first word it finds is the name of the command to be executed, and the remaining words become arguments to that command. It is important to have at least one white space to execute the command properly. Otherwise, system will return the error message command not found as shown above. If you need to run several commands, chain them with a semicolon. It's a control operator or meta character. General syntax would be command 1 semicolon, command 2 semicolon, command 3. So in the example above, when the shell sees a semicolon in a command line, it's treated as a command separator, basically like pressing the enter key to execute a command. The pw command is a command line utility for printing the current working directory. It will print the full system path of the current working directory to standard output. The pw command shows home /u9 /Abu Agil. Home is the home directory. U9 means user number 9. Abu Agil is the user ID. The change directory cd command is built into the system shell and changes the current working directory. The cd command can be used to either change to a directory that's relative to the location of the current working directory, or to an absolute location in the file system. In this example, you can change to APCV 320 directory by typing cd APCV 320 and pressing enter. To check if you are inside that directory, type pwd, then you will notice that you are inside that directory. ls command lists the names of files in a particular UNIX directory. If you type the ls command with no parameters or qualifiers, the command displays the files listed in your current working directory. ls lists the names of files in your default directory in alphabetical order. ls space -l gives a long listing of the files in your directory. In addition to the file name, the long listing shows protection information, file owner, number of characters in file, and the date and time of the last change to the file. ls space -a causes all your files to be listed, including those files that begin with a period, i.e. hidden files. In this example, we executed ls, then ls space -l, then ls space -a. Notice the difference between the three commands as explained previously. Dot means the current directory you are in. Dot means the parent directory of the current directory you are in. Executing the following commands gives you the output shown above. As you notice, dot specifies current directory, while dot refers to the parent of the current directory. In Linux, the dot character denotes the current directory. In other words, it's a command that evaluates commands in a computer file in the current execution context. In the above example, single dot represents the current directory. Dot means the parent directory of the current directory you are in. In the above example, double dot represents the parent directory. The mkdir command in Linux/Unix allows users to create or make new directories. mkdir stands for make directory. With mkdir, you can also set permissions, create multiple directories or folders at once, and much more. The mkdir command is a straightforward command that allows you to make one directory at a time or make more than one directory by separating the directory names with white spaces as shown above, i.e. mkdir space python files space data. cp is the command used in Unix/Linux to copy your files or directories. Copies any file with the extension .txt to the directory in UDIR if the files do not already exist or are newer than the files currently in the directory. In the above example, we copied caesar.py to another file called caesar1.py, and we also copied turtle.py to another file called turtle.txt. To copy a file to a directory, specify the absolute or the relative path to the directory. When the destination directory is omitted, the file is copied to the current directory. When specifying only the directory name as a destination, the copied file will have the same name as the original file. This slide shows more examples on how to copy to directories. In the above example, we copied turtle.py and the twin_turtle.txt files to a folder named layer. To remove a directory and all its contents, including any subdirectories and files, use the rm command with the recursive option -r. Directories that are removed with the rmdir command cannot be recovered, nor can directories and their contents removed with the rm space -r command. The above example illustrates the removal of file and directory remember that the directory has to be empty in order to remove it. rm space -I will ask before deleting each file to confirm. rm space -R will recursively delete a directory and all its contents. Normally rm will not delete directories, while rmdir will only delete empty directories. rm space -I will ask before deleting each file to confirm. In the example above, notice that you have to answer with Y for yes in order for the file removal process to be completed. The mv command moves files and directories from one directory to another or renames a file or directory. If you move a file or directory to a new directory, it retains the base file name. When you move a file, all links to other files remain intact, except when you move it to a different file system. As stated previously, the mv command moves files and directories from one directory to another or renames a file or directory. In the example above, notice that we moved turtle.py as a file to another file named new_turtle.py. As you see, turtle.py is no longer available inside the folder layers. In some operating systems, including UNIX, the tilde is used to represent the current user's home directory. On web server systems, the tilde is used by convention as the first character for any user's home directory in the file system. In the above example, notice how tilde symbol will change the directory cd tilde brought us back to the home directory. A wildcard in Linux means it might be a symbol or set of symbols representing other characters. It's generally used in substituting any string or character. Wildcards are mainly used to increase the efficiency and the flexibility of searches in Linux. The wildcard asterisk means it will match any number of characters or a set of characters. For example, S ** N will match anything between S and N. The number of characters between them do not count. Wildcards are interpreted by the shell, and the results are returned to the command you run. There are three main wildcards in Linux. An asterisk matches one or more occurrences of any character, including no character. Question mark represents or matches a single occurrence of any character. Bracketed characters matches any occurrence of character enclosed in the square brackets. It's possible to use different types of characters, alphanumeric characters like numbers, letters, other special characters, etc. Redirection is a feature in Linux such that when executing a command, you can change the standard input/output devices. If the notation greater file is appended to any command that normally writes its output to standard output, the output of that command will be written to file instead of your terminal. Unix-like operating systems feature the concepts of standard streams of data. Each process is automatically initialized with IE assigned 3 data streams, one input stream called standard input and 2 output streams called standard output and standard error. These streams consist of data in plain text, i.e. human readable characters, and are considered to be special types of files. A process is an instance of an executing program. The example above shows an error as we tried to ask the interpreter to use 2022 as a month value. We got an illegal error message as the month value should fall between 1 to 12. And as an example of an error message, the cat command, among whose functions is to read the contents of files, will produce an error message if an attempt is made to use it to read a non-existent file, such as a file named nofile, i.e. cat nofile. In this case, an error message similar to the following will appear on a new line on the monitor screen. Because the standard error was not redirected, error message will show as cat no file, no such file or directory. Unix recognizes 3 standard input and output streams called the standard input stdin, standard output stdout, and the standard error stderr. Redirection is a feature in Linux such that when executing a command, you can change the standard input/output devices. The basic workflow of any Linux command is that it takes an input and gives an output. In the above example, standard output and the standard error can be combined with the to greater redirection operator. The pipe command is used in both Unix and Linux operating systems. Pipes help combine 2 or more commands and are used as input/output concepts in a command. In the Linux operating system, we use more than one piping command so that the output of one command before a pipe acts as input for the other command after the pipe. Who command is a tool to print information about users who are currently logged in. Who command only sees a real user who logged in. In this example, who command showed the users on the system at that timestamp. You can use who with word count WC, vertical bar character as the pipe symbol, and -L to count the number of users, i.e. who space vertical bar WC space -L. In this case, we have 3 users. A variable in bash is created by assigning a value to its reference. Although the built-in declare statement does not need to be used to explicitly declare a variable in bash, the command is often employed for more advanced variable management tasks. A variable is a character string to which we assign a value. The value assigned could be a number, text, file name, device, or any other type of data. A variable is nothing more than a pointer to the actual data. The shell enables you to create, assign, and delete variables. In the above example, we used echo command, which is a built-in Linux feature that prints out arguments as the standard output. Echo is commonly used to display text strings or command results as messages. Command substitution is a mechanism that is followed by programmers in a shell script. In this mechanism, the output of a command replaces the command itself. Shell operates the expansion by executing a command and then replacing the command substitution with the standard output of the command. In simple words, the output of a Unix command is bundled and then used as a command. In the above example, we used $, open bracket, who, space, vertical bar, WC, space, -L, close a bracket, to show the number of users in the system. In other words, the output of a UNIX command is bundled and then used as a command. You can control the execution of UNIX commands in a shell script with control structures. Control structures allow you to repeat commands and to select certain commands over others. A control structure consists of two major components, a test and commands. If the test is successful, then the commands are executed. In this way, you can use control structures to make decisions as to whether commands should be executed. There are two different kinds of control structures, loops and conditions. A loop repeats commands, whereas a condition executes a command when certain conditions are met. The bash shell has three loop control structures, while, for, and for n. There are two condition structures, if and case. The above example shows the use of if, then, else control structure. The execution of the then condition took place over the else condition because Abu Agil is working online. Notice that FI statement is the fundamental control statement that allows shell to make decisions and execute statements conditionally. So that was a lot to go through and digest. I encourage you to practice as many of these commands as you can. This will build a good foundation toward UNIX and shell programming. This will be the last module in our class, and I hope you enjoy it.